So now, we're going to look at the photodiode. It's reverse bias. We got the cathode towards the positive supply, and then the anode to the resistor. This resistor is going to limit the maximum current. It's not what sets current, unless, we get too much light on it. So that'll set a maximum. But we are also going to bridge this gap with the multimeter so we can measure current. So now here's the schematic diagram that I drew a long time ago. Again, this is not dependent on voltage or the value of that resistor right there. It's how much light is falling on the photodiode, and you could call it light dependent diode as well. So it's a diode symbol. We got it circled. I don't know if everybody circles it, but there should be arrows pointing in to indicate that it's responding to an incoming source, in this case light. So now I got the multimeter, and we can see the supply voltage that we are applying to the circuit. Of course, no current's flowing through it right now. It also has to flow through the meter so we can measure it. Milliamp range is good enough for our purposes there. I'm purposely keeping the current kind of low, so we're just going to use this overhead lamp lighting right there. And so I'm getting the glare out of the way. Not sure exactly what we'll end up getting, but to take our measurement, instead of holding the probes against stuff, which will cause, like, even if you try to hold it steady, minor vibrations and stuff, which will affect the reading, I'm going to take these alligator clips that I crimped just with a pair of pliers to breadboard wire. So the other end looks like that, but I clamped on an alligator clip with pliers, as I said before. So there we go, about 25 milliamps of current. If I move the lamp away, of course it goes down a little bit. I get it closer, it goes up a little bit. But let's try to lock it in at about 1.25 milliamps. I think I said 125 before. But 1.25 milliamps basically. So we're going to double the voltage. If we were using the resistor to limit the current, we would get twice the current. But instead, you're going to see it does go up a little bit, I think due to the photodiode warming up as we get more voltage on it, because that's what it's doing. It's, passing a certain amount of current, and the rest of the voltage that builds up across it is going to be waste heat right there. So it might change a little bit as it heats, but for the most part, it's pretty close to exactly the same. We'll go to 5 volts, or I could have did this while we're still 10 volts. I'm going to dim the lamp right there. So it looks like we're getting about 1/5 of the current, and I'm guessing the lamp is 1/5 as bright as it was before. I don't know for sure. I do have a meter that can measure light level, so maybe I'll do that later. But again, about 0.25 milliamps of current, approximately. And we double the voltage. If this was a resistor base component, like the light-dependent resistor, we would have got double the current. But we don't, because it's a photodiode. It responds to how much light is hitting it to determine how much current it passes. Again, the resistor is just to limit the maximum. It's not setting the current at all. And if I got a bright enough light, probably would get more current than what the 220 ohm resistor can handle. So I would actually probably use like 1,000 ohm resistor in a 12 volt circuit, 10 volt circuit or so, instead of 220. But most of the time, I'm going to work with like 5 or whatever. So 220 is probably okay. And also, it's the photodiode limiting the current, not the resistor. Now, that's really about it. So let's undo these so that we're not measuring anything when I change the meter there. But you always want to get it off of measuring current. If I tried to measure a voltage right now, I have this limited at 20 milliamps of current, but you may get a brief spike of higher current. But in any case, I got the current limited there, but if I didn't, then, or if I put it up to the maximum current in the amp range, this is only set to measure milliamps of current. I believe 600 is the maximum right there. So if I set that to like 3 amps and we shorted the probes, this does have short circuit protection. Hopefully that would kick in, but if not, we would blow a fuse in here. So we don't want to do that. Best way to avoid doing that by accident is to turn it off, because it's really easy to think that you get it off of measuring milliamps of current, even if you have a power button, because it's really easy to think you're going to be measuring voltage, that it's set to voltage when you try to measure a voltage, and if it's set to measure current, it's a short circuit. High current's going to blow the fuse. So I try to remember to say that every time I measure current, at least briefly mention it, I mean. So, in any case, hope you enjoyed. Make sure you check out one of the other videos I posted on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.